Good day, my name is Tobias van Reenen. I am with the Council for Scientific and Industrial Research in South Africa, and today I'd like to share some basic principles with you on the measurement and maintenance of upper rim GUV fixtures. The maintenance of artificial lighting systems in large facilities like healthcare facilities is often based on preventative maintenance philosophies. In these preventative maintenance philosophies, your maintenance activities are often triggered by component age and not the condition of the component. And the strategy is appropriate when your asset base is large enough and homogeneous enough such that the component condition can be reliably predicted by age, but it requires that the cost of your interventions, manpower, etc., at a unit level is significantly higher than the component costs. So that gang replacement and wastage is offset by the savings in maintenance costs, manpower. However, these requirements don't necessarily hold true for UVGI installations in healthcare facilities, as UVGI installations will have significantly lower numbers of units within the facility, and the cost per unit is significantly higher than you would find for artificial ambient lighting. The predictive maintenance programs may therefore be more appropriate for ultraviolet systems. Your predictive maintenance activities, as opposed to the preventative maintenance activities, are triggered by component condition and not component age. And the component condition must be monitored and recorded. This is not to say that run to failure strategies for certain components is not appropriate. For instance, your ballasts or your lamp holders could be kept in stock and replaced as needed and on failure, because monitoring and predictive replacement of these components is significantly more difficult. The table here shows the difference between some of the interventions of predictive versus preventative maintenance strategies. For instance, typical preventative maintenance interventions you would have heard of would be, for instance, to clean the louvers every 3 months or replace lamps at every 9,000 hours, regardless of the condition, whereas the predictive maintenance strategy would require cleaning of louvers at intervals found to drop device output by 15%, or to only replace lamps where the output has dropped by more than 30%. Just getting back to the cleaning of louvers, the proposal here is to measure the output of the lamps after cleaning, the output of the devices after cleaning for a period of time to determine what the cleaning interval appropriate for your facility is, and not to adopt those from other facilities that would have different ambient conditions demanding different cleaning periods. It's important to recognize that monitoring is maintenance, and predictive maintenance requires monitoring. This diagram is quite a simplified maintenance life cycle. You'll see the component life cycle itself starts with a design phase. The design phase would lead to an installation and commissioning phase, and then from installation and commissioning you would move on to planning, which informs monitoring cycles and activities, and then your monitoring activities inform your maintenance activities or your maintenance interventions. So there's a feedback loop there from your maintenance back to your plan, which means that as you're doing your monitoring and maintenance interventions, you need to come back at a regular interval and review and update your maintenance plan, so that that plan is most appropriate and most efficient for your own system. At some point, various components will need to be disposed of. You might even need to dispose of an entire system after a period of time, which would trigger a new design and installation cycle. In order to monitor your UVGI system, you require predefined performance criteria. This is because your performance criteria for every system you may encounter is not identical, and your designer or system supplier should present you with operation and maintenance manuals which prescribe the performance monitoring criteria. These performance monitoring criteria are usually the form of a minimum irradiance value with a defined position for the measurement of that irradiance value, as well as a method of measurement, including measurement equipment specifications. In the absence of designer's prescribed monitoring criteria, this value is typically about 250 microwatts per centimeter squared, which should be measured normally at 1 meter horizontally from the center outside face of the device. Note that monitoring performance criteria are minimum values, which means that new device commissioning criteria should be about 43% higher, which is a function of the 70% lifetime depreciation of those lamps. This would imply that for new systems, that's the commissioning of new systems, you should be achieving something in the area of 357 microwatts per centimeter squared. When dealing with brand new systems with brand new lamps, you should be aware that any new or unseasoned lamps can temporarily achieve a significantly higher output than the output declared as a stable maximum by the manufacturer. This means that before the first performance measurements of any system with new lamps, that is, those lamps should be seasoned for about 100 hours. Of course, you should always follow the manufacturer's recommendations, as this effect we're talking about can vary between brands. If the manufacturer, however, does give no information on this, ensure that you're applying 100 hours of seasoning before your first measurements. The highest concern for UVGI, specifically for UVC, is eye safety. Eye safety limits for UVCs prescribed in the ISO standard, ISO 15858 of 2016. From the standard, in Table 1, recommended eye exposure limits are given for an 8-hour workday. For an 8-hour workday, this is 0.2 microwatts per centimeter squared. However, the standard does take note that peak meter readings frequently overestimate real-time exposure for upper room UVGI cases, and therefore with threshold limit values should rather be derived from better data like real-time occupancy data when this is available. In order to do monitoring and measurements of the performance of your upper room UVGI systems, you need a radiometer. A radiometer is essentially photodetectors with a narrow band filter for UVC that is in the range of 254 nanometers. It is important to be filtering out UVA and UVB so that you are only measuring the UV in the 254 range, so that your measurements are not affected by sunlight specifically. Your radiometer should preferably include a cosine response diffuser. That cosine response diffuser increases the effective angle, making the devices more usable, and they also offer some protection from sensor saturation for very close-up measurements and other types of applications of UV. Additionally, filters can be sourced for high-intensity measurements. For instance, if you're going to use the device to measure UV tunnels or surface disinfection systems. Your preferred accuracy for upper room UVGI systems, you would require a radiometer with an accuracy of better than 1 microwatt per centimeter squared for performance measurements, and for eye safety measurements, it would probably have to be better than 0.1 microwatts per centimeter squared, ideally. Your personal protective equipment relate to your eye safety and also protection of the device from contamination. So for eye safety, all you need are a basic pair of safety glasses. Plastic safety glasses are adequate. Don't only use your eyeglasses as safety glasses because there is ample evidence of cases where reflections from behind reflecting into eyeglasses can cause severe eye irritation. So if you have to wear your own eyeglasses while you're doing work in the upper room, just make sure that you have goggles over your eyeglasses as well. And then to protect the device from contamination from your hands, you need to use cotton gloves. Clean cotton gloves prevent the residue from your hands from contaminating the lamps and thus reducing the output of the lamps. Don't use latex gloves or nitrile gloves or rubber gloves, as these can also leave deposits on the lamps, especially if the lamps are hot, and as a rule don't handle hot lamps. Even though you have received initial performance criteria as established by the designer or system installer, you need to perform an initial performance review or commissioning test. You should use these tests to validate that the system does in fact perform in accordance with the criteria established by the functional specification in the design, and you should keep records of the performance measurements of new systems for potential use in reviewing monitoring plans and in future maintenance cycles. These tests are done not only on new systems, but also after any engineering changes. These engineering changes could include deviations from specified lamp models or deviations from prescribed or specified ballasts. They should also be done after structural changes to any UVGI device, that is changes or repairs to device enclosures, device louvers, or any changes to the coating, that being repainting or refinishing of the device. In addition to that, performance review testing or commissioning testing should be done after any architectural change or changes to the interior finish of the room in which they are installed. The commissioning tests include device performance validation at 1 meter, room reflective measurements, as well as eye safety assessments. With these initial eye safety assessments, it's important to keep your records as reference for future assessments and for any health and safety reviews. Now, your routine testing and inspections need to be as simple as possible. You want them to be simple but yet effective. You don't want to commit to too much activity at each inspection. Otherwise, this can become quite an onerous exercise. So we should be doing device inspection for defects, first making sure that all the devices in the room are off. And with those devices off, you visually inspect the units for any potential problems. And then with only the single device that you're going to measure on, you measure its irradiance at 1 meter. That's done using your radiometer. You can mark the location of measurement points on the floor or the ceiling so that these points are easily referenced and repeatable for future measurements. And you should apply then corrective actions for any out of specification units. And your corrective actions would include things like cleaning, replacement of any consumables, and repairs to the device. Then all of your activities need to be recorded in a facility logbook. An example is provided on the slide. The maintenance and cleaning of UVGI devices need not be technically difficult or onerous. Just make sure that you are aware of some cautionary notes in your procedures. Firstly, you need to turn off your fixtures to let the lamps and control gear cool. These can get quite warm, and you don't want to handle them in that state. You might harm yourself or the device. Then, once cooled down, open up the unit to the manufacturer's instructions. Some units do open much more easily than others. Some devices require a significant amount of disassembly to get into the unit to clean it. So this is something you just want to be aware of when you are specifying or procuring new systems. Make sure that the ones that you procure are easily maintainable. Once it's all open, handle the lamps or any reflectors with clean cotton gloves to prevent oil deposits from your fingers, decreasing the efficiency of the lamps. Also take note that rubber gloves, nitrile gloves, or latex gloves can also leave deposits on the surfaces and lamps, which will also decrease efficiency. This is especially true if your surfaces and lamps are still warm. Then you'd want to change out any lamps that have failed. This failure could be from low output or flickering. You would want to change the ballasts of devices that are still flickering even after lamp replacement. And then you also want to remove any loose dust or debris from inside the device before you do any wet cleaning. Wet cleaning of the lamps, for instance, is done with an alcohol dampened cloth. Do not use water. Water, and especially soapy water, can leave residues on the surfaces, reducing efficiency and output. And then you want to dry the lamps with a soft cotton cloth. Use lint-free cloths. You don't want to leave any debris inside the device. Close up the fixtures, and then making sure that you have not forgotten to put on your PPE, turn on the system and verify lamp operation. If there are any problems with the system still, like the flickering lamps, you might want to go back into the device to make any further necessary repairs or replacements. Then record your inspection and cleaning and replacement in your maintenance logbook. Decommissioning of GUV systems can be a little bit tricky, as the low pressure mercury vapor lamps can contain mercury vapor, or do contain mercury vapor, and are considered as hazardous waste. You should wear appropriate PPE when there's a risk of breaking the lamps during handling or disposal. This PPE includes gloves, obviously for glass cuts, etc., safety glasses, and most importantly, respiratory protection, as the mercury in the lamp is in the form of a vapor. You should use a certified waste handling company to dispose of or recycle all mercury vapor lamps, together with all the fluorescent lamps in your facility. This is to ensure compliance with local regulations, and also you should be keeping records of all the hazardous waste disposal contracts and activities on your facility, and this should be including your fluorescent lamps and UVGI lamps. I trust this was informative. Thank you very much for your time.